Hello friend, in this video I'd like to summarize ionic bonding and covalent bonding. Let's begin with ionic bonding. And let's write down a few key things that I want you to know that you certainly should have seen before in prior courses. So first of all, in ionic bonding, atoms gain or lose electrons and become ions. All right, second, ions can be positively or negatively charged. Maybe that's obvious to you, but maybe some of you are not familiar with that. So for example, sodium can be positively charged and chlorine can be negatively charged. Chlorine atom can be negatively charged. All right, so thirdly, negative and positive ions are drawn together. Or attracted to each other. Of course, ions with the same charge are going to repel one another and not form a solid, liquid, or gas usually. All right, so this is called this is called something that you've certainly seen before, and this is called Coulombic attraction. And a simple example of that is that the sodium ions and the chlorine ions combine to form NaCl, which is a salt. All right, and so some general properties that we should keep in mind of ionic bonding. First, they are usually stable, hard crystals. Second, they are often or usually poor conductors of electricity. Why? Well, because they have no free charges or no free electrons to conduct. Thirdly, there's often a high vaporization temperature. So they don't like to become vapor very easily. And then lastly, last property I'd like to highlight here is that they are very often soluble in water. And that's, of course, because water is a polar molecule and can easily pull apart the ionic bond. And that is quite obviously seen in salt water. Next, I'd like to consider with you the properties of covalent bonding. And these also you should be familiar with, but let's write them down so that we're sure how it's distinct from the other kinds of bonding. First of all, it's when two atoms share their electrons. And neither atom has sufficient strength to steal the electron completely. And another way to think of this is that the orbitals overlap. And it's very much like we drew before, where we had a nucleus of one atom close to the nucleus of the other atom, and the orbital, or the orbitals from one atom, take up a certain amount of space here. And then in covalent bonding, the neat thing is the orbitals of each of them, each of the two separate atoms, overlap, and they form this process that I've just tried to illustrate here is this overlapping of the orbitals, and this forms a kind of mutual molecular orbital that is really a combination of them interacting. All right, well, what are their properties in general? Well, the first important property is that it's a highly stable bond. It's something that leads to usually very strong materials. For example, among the strongest materials that we know, diamond. And of course, that's formed with covalent bonds. And because of these very strong bonds, a very high temperature is needed for melting. And then lastly, they're also poor electrical conductors in general. Why? Because again, there's no free electrons. All right, well, that's it for now.